You probably picture, like, aerospace labs, or maybe a Formula One car when you think of high-end engineering. You don't usually picture a $435 cable hiding behind the drywall of some boring conference room.
Right. I mean, that invisible infrastructure is something we just take completely for granted, well, right up until the moment a presentation screen goes blank.
Exactly. So in today's deep dive, we are looking at one very specific piece of AV equipment. It's the DVIGear DVI-2330-AOC-M. It's a 30-meter video cable, and for anyone who loves learning how the hidden world actually works, we're unpacking why this seemingly mundane wire is actually a brilliant lesson in problem solving.
Yeah, to justify a price tag like that, you really have to look at the physics of sending a signal across 30 meters. I mean, this isn't your standard copper wire. It's an active optical cable, meaning it relies on light.
Which is wild for just a display cable.
It really is. And it's built to handle data rates up to 4.95 gigabits per second, fully supporting HDCP 1.4, which is basically that digital handshake between devices that prevents piracy.
Right, because sending nearly 5 gigs of data a second across almost 100 feet of pure copper usually results in, like, massive signal degradation. The data essentially just runs out of gas before it even reaches the screen.
Exactly. Which is why this specific cable uses a hybrid construction. It mixes 4 polyfluorinated optical fibers. That's a highly specialized type of plastic fiber directly with 6 traditional copper wires.
Wow, so they're literally bundled together.
Yeah, because copper just degrades too quickly over that distance for heavy video data. But, fiber alone can't carry the electrical power needed to actually wake up a monitor.
It's kind of like a city transit system, right?
Yeah.
The optical fibers are the high-speed bullet trains. They carry the heavy, data-dense video signals across that 30-meter stretch at literally the speed of light.
That's a great way to put it.
And meanwhile, the copper wires are like the local utility trucks on the side roads, handling the essential power delivery and those baseline security handshakes, so the whole system actually operates smoothly.
Right, but that hybrid approach, while it gets the data there efficiently, introduces a massive physical problem.
Oh, because of the size.
Yeah, you now have this thick cable with a bulky DVI connector on the end, and you have to somehow thread it through tiny pre-existing pipes inside a wall.
Which is just an installer's absolute worst nightmare.
Oh, 100%. So the engineers solved this by making the DVI docking connectors fully detachable. Like, when you pop the heads off, the cross-section of the cable shrinks down to just 13.9 by 14.2 millimeters.
Wait, really? That's roughly the width of a standard AAA battery. That is so much easier to work with.
Exactly. They even include these fixation screws and cable pull covers, so you can securely attach a guide wire and drag the cable through narrow conduits without, ripping the internals apart.
But wait, pulling fiber optic lines through a 90-degree wall conduit sounds like a total disaster waiting to happen. I mean, fiber is essentially glass or rigid plastic. Doesn't standard fiber just snap under that kind of tension when you force it around a sharp corner?
Normally, yes, absolutely. And that is the specific problem those polyfluorinated optical fibers solve. They have a minimum bend radius of just 2 millimeters.
2 millimeters.
Yeah. You can practically fold the cable in half, and the internal reflection keeps the light flowing without breaking the core.
Meaning you can just yank it around tight, uncompromising corners without destroying a $400 investment. That is incredible.
And you can do it safely in commercial spaces, too. It carries a UL-CMP-OF plenum rating.
Which means what exactly?
Basically, this means the jacket is fire-resistant enough that building codes legally allow it to run through air circulation ducts, so you don't run the risk of spreading toxic smoke if a fire breaks out in the building.
We interact with screens every single day. We expect instant, crystal-clear video the second we plug a device in. Completely unaware of this, like hyper-flexible microengineering hiding in our walls, making that seamless experience possible.
We really are going to extraordinary lengths just to manage the data bandwidth we require right now.
It really makes you think. If we are deploying detachable hybrid fiber copper cables just to send single-link DVI video across 30 meters today, how radically will the physical architecture of our buildings need to adapt to house the massive terabyte per second wiring of tomorrow? I mean, next time you look at a blank wall, just think about the high-speed transit systems hiding right behind the drywall.